everyone, in this video we are going to see the page replacement algorithms. So what does page replacement algorithm mean? In an operating system that uses paging method for memory management, page replacement algorithms helps in deciding which page needs to be replaced when the new page comes in. So the page is replaced into the frame. So there are three types of page replacement algorithms. The first one is FIFO, first in first out. The second one is LRU, least recently used, and the third one is optimal algorithm. In this video, we are going to focus only on FIFO, which is very easy, the simplest one, and I'm going to explain you FIFO with the help of an example. So there are two basic things that you have been given in order to solve the example, that is reference string and the frame size. What is frame size? It is the maximum number of pages that could be inserted into the frame. So let me write the reference string here. It is 7 0 1 2 0 3 0 4 2 3 0 3 0 3 2 1 2 0 1 7 0 and 1. Now you're good to go. So first of all, there are two terminologies in the FIFO, that are page fault and page hit. What does page fault means? Talking about the literal terms, it is a memory page that is mapped into the virtual address space but not loaded into the physical memory. It means that you're having a frame, you're searching for an element, but it is already present into the virtual address space. It is already present, but it is not loaded into the physical memory. That is called as page fault. But if the element is already loaded into the frame, it is called as page hit. So let's start with an example. Here the frame size is 3, so you need to draw 3 boxes. This is our frame. It is initially empty. The frame here is empty. Now when you have to put 7, you don't have to decide anything. There is no algorithm needed because the frame is empty, so you can directly put the first element. So I'm putting 7 here. Now this is called as page fault because we did not found any 7 which was present already, because it is the first element. Now moving on, we are having 0. So for 0, do we have 0 present here? No. And since the frame is empty, we can put 0 directly without any decision. So 7 0. This is called as page fault because we did not found 0 earlier. Now we are having 1. So for 1, do we have 1 here? No, we don't have. So just directly put it 7 0 1. This is also page fault. Now what happens here? The frame is full. It is full, as you can see. Now the real algorithm comes into the picture, that is FIFO. Now you want to insert 2, but the frame is full. What to do now? Here FIFO states that the very first element that you have inserted into the frame needs to be replaced by the new element that needs to be inserted. So here we replace 7, since it is the very first element. We replace 7 by 2. So write 2 here, 0 and 1. So this is also page fault because 2 wasn't present already. Now for 0, what do we do? For 0, we are having 0 already here. It is already present, so we don't need to do any replacement. So we can write it as it is, 0 1 and 2. This situation is called page hit because it was mapped into the virtual address space and it was also mapped into the physical memory. So this is page hit. Don't go into the literal terms. You can directly think it of like 0 is present here and we don't need to do any replacement. So just keep the frame as it is. This is a page hit. Now we go on to 3. So for 3, do we have 3 here? No, we don't have. So we need to replace. We need a replacement. So which was the very first element among these 3? After 7, 0 was inserted, as you can see. So replace 0 with 3, 1 and 2 as it is. This is page fault since we required replacement. After 3 there comes 0. So for 0 we don't have 0 anywhere present here. We need to replace. After 0, 1 was put into the frame. Replace 1 with 0. 3 and 2 as it is. Mark it as page fault. Keep marking this because this will help in the final count. Now we are having 4. Since we don't have 4 here present in the frame, we need to replace. So after 1, which element was put? It was 2. Replace this 2 with 4, 3 and 0. This is also page fault which we put here. Just keep a track of this also. Now we are going to put 2. So draw a table here. Sorry, the frame. 2 is not present anywhere here. So we need to make a replacement. After 2, 3 was entered. So just cut this 3 and put 2 here. Don't forget to write this 2 here. Here 0 as it is and 4 as it is. So this is page fault. Now for the next element, that is 3. We don't have 3 already present, so we need to replace. So 0 was inserted after 3. So 0 should be cut. 3 should be put here. 2 and 4 as it is. This is also a page fault. Next we are having 0. So for 0, do we have 0 present here? No, we don't have. We need replacement. So after 0, which was replaced, 3 was replaced by 0. Sorry, 0 was replaced by 3. So after 0, we entered 4 into the string, into the frame. So just cut this 4 and insert 0, 2 and 3. So this is also a page fault. Next we are having 3. Now you can see clearly that we are having 3 present here already. So we don't have to make any replacement, no changes, nothing. Keep the frame as it is. So 3 will be written as it is, 2 and 0. Now this condition is called as page hit. It's called page hit because the element, the memory page was present it was mapped into the virtual address space, and it was also loaded into the physical memory, so it is called as page hit. After that we go to 0, and here 0 is already present, so no need to make any replacement. Keep 0 as it is, 2 and 3. This is also called page hit since we did not make any replacement. Now we are having 3. So 3 is already present here, no replacement, nothing, so keep it as it is, 2 and 0. This is also called as page hit. So after that we are having 2. 2 is already present, so write it as it is, and this is also a page hit. Now after 2 we are having 1. Is 1 present here? No, it is not present, so we need to make replacements here. So after 4, 2 was inserted, so cut this 2 and write here 1. 3 and 0 as it is. These would stay as it is. Since we replaced this 2 by 1, so this is page fault since we made replacement. After that we are having 2. So draw a table, make 3 compartments. So for 2, do we have 2 here already? No, we don't have, so we need to make replacement. Here after 2, 3 was inserted into the queue, so just cut 3 and put 2 here. 1 0 as it is. Here we made replacement, so it is page fault again. Now we are accessing 0. So for 0 we are having 0 already present here, so we don't need to make any replacement. Keep it as it is, and here we write page hit because we did not made any changes into it. After that, what element do we access next is 1. Do we have 1 here? Yes, we do have. We don't need to make any replacement. 2 as it is, 0 as it is. This is also a page hit. After that we having 7. So for 7, do we have 7 here? No, we don't have, but the first element that was inserted among this was 0 because here we cut 3. After that 0 was inserted, so cut this 0, put 7 here, 1 and 2 as it is. Here we made replacements, therefore it is page fault. And after that, the last second element, it is 0. 0 is not present here. The very last replacement, 0 is not present, so we need to replace the very first element which was inserted among these three. It was 1, because after 0 there is 1. Cut this one, put it 0, 2 and 7 as it is. So this is page fault again. The very last one, the very last element, that is 1. So here 1, and there is no 1 present already. We need to make the replacement, and we need to change this 2 because it was inserted firstly among these three. 1, 0 and 7. This is also a page fault. So here your process terminates, and the very last thing that you need to count is the total number of page faults. Hits don't really matter, because the efficiency of algorithm is decided by the number of page faults, and lesser the page faults, more efficient the algorithm is. So number of page faults are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. So the total page faults we have here are 15. So that's it, and this is all from this video. I hope you guys got the page replacement algorithms and the FIFO algorithm. Thank you. I forgot to mention there is one more important point, that is Bellardi's anomaly. It proves that there is a possibility of having more page faults when increasing the number of page frames while using the FIFO page replacement algorithm. It means that, for example, for a frame size of 3, the page faults are 10, for example, and the frame size of 4 is having page faults 11. So this is nothing but these have increased. So this is the Bellardi's anomaly. That's it, guys. Thank you so much for watching.